So my name is Duann Scott, and in this instance, I'm talking on behalf of the 3MF Consortium. If those who don't know, 3MF file format is developed by a consortium of software, hardware companies in the additive manufacturing space to develop a file format for 3D printing. So it's a format for communicating more than just geometry. And at the very base level, it's a more compact, smaller file, which is always watertight. So comparing to the dreaded STL, just for file size difference, it's typically a third to a quarter to size with no effort required. So you just export 3MF over STL and you're already winning. This is particularly important when you get to more complex designs like ladder structures, heat exchangers, anything with advanced design, then you'll really see the big difference. And if you have to send data across networks where gigabytes of information is problematic. So baseline, you get a smaller file size and it's always watertight. So a 3MF mesh is always watertight. There's never any reverse triangles. You're always going to be able to print the file, slice it. So that's the base level. So that's not too hard to get on board with. But 3MF also has data other than just geometry in its communication stack. And if anyone has any questions, you can interrupt me as we go because I think it's more interesting that way. So if we look at one of the extensions is a beam based for ladder structures, again, you can see the file size difference in this initial thing, the brake pedal you see here. You can barely see the size of the 3MF versus STL just because what we're doing is we're communicating the lattice structure as the endpoints of the lattice beam and the diameter of the beam. So it's basically a series of cones in a graph. And when you're describing the geometry this way, there's no need for decimation, there's no need for reduction in quality. So you get the perfect communication of the geometry, and then the slicer takes information and makes it into a slicer. So the extensions include the core spec is basically a mesh format, again, similar to STL, except the way it's communicated is more efficient because of the data structure isn't 40 years old. There's a materials extension, which is both materials as in, like if you have like a bellow machine, you could describe parameters for materials. And if you have an object machine, you could describe material itself. And if you have a full color machine, it's for colors. The slice extension is just that. It's communicating the geometry, which includes the mesh as well, which can be used for rendering, as well as the slice information. Production extension is used extensively by HP for the job ticket for a part. So it's not just the geometry, it's also the machine, material, process, layer height, etc., and which machine it's going to. Beam lattice extension, as discussed, the ladder structures, communicating that more efficiently. The secure extension is a new one that's been working on, so securing the data so it can go to a particular machine for a particular amount of print times. Again, this is being led by HP, but other manufacturers are bringing this on board slowly. The beam, lattice, and ball extension is basically an extension upon the beam extension, but including balls in the ladder structure, so you get a better ending. And then the volumetric extension is something we're working on at the moment, which describes the geometry as either a voxel sheet in a bitmap stack or as implicit. So let me show some examples about why this is important for end users. So this is a metal event, but the material could be multi-material as well. In this instance, we have a full color print coming from Luxian Keyshot going to Stratus's full color 3D printer. An application here is for prosthetics, making sure skin tones are right. We see band-aids are all the same color. It's not cool if you're a person of color to have a white band-aid on. So in the same way, having a skin tone prosthetic is important to have the right skin tone. So this is something that's really important. It's and made possible because we have like Pantone colors into the 3MF color format. The volumetric extensions are interesting. This is a project by Additive Low and Zeiss. This is a housing mount for a sensor in a nuclear reactor. And by defining the parameters using simulation, I think they're going to say it's using AI to find the the best parameters between surface density and conductivity. But here we see by using the 3MF to communicate the parameter sets, you can have a 45% mass reduction, 50% increase in speed because you can run a laser faster where you don't need the same density, and a greater thermal performance by changing the metrology of the metal through parameters. And this is because we're describing every voxel of every layer. Again, with additive flow, they're kind of the most advanced one for communicating the volumetric extension at the moment. But we have a group of startups who are about to adopt it. You'll see information about that coming online soon. So again, what we're doing is we're communicating more than just the outside surface of an object. We're describing what's happening in every voxel. In this instance, it's machine parameters, which is going to NetFab, advanced toolpath utility, which can then assign different parameters for each spot. Again, talking about the file size from the ladder structure, this is going from NTOP into Magix. So most of the major software now supports it, most print prep software, so Magix and NetFab being the two major ones. Companies like Velo don't even accept STL anymore. So it's kind of becoming more default in communicating geometry to printers. Another example of the file size difference. And this is the most recent one we're working on at the moment in the volumetric spec is implicit communication. So most major CAD companies now have some form of implicit for doing complex heat exchanger type geometries at the moment. This is a project with Anthropology, Siemens Energy, and EOS where they communicated a massive heat exchanger. I think the file was in the end 680 kilobytes, which would have been, just impossible to communicate via slices and meshes to any machine. We expect this to be ratified in the next 6 months. So by mid next year, it should be in the volumetric extension for 3MF. These are just some of the companies involved in the consortium. It was originally started by Microsoft, which made it possible to bring in otherwise competing CAD and hardware companies to communicate to bring this spec together. There's been other projects in the past, such as AMF, to try and advance a new file format for additive manufacturing, but just wasn't the industry push as there is now. And we're getting real momentum now. So just about every machine and software company now supports 3MF in one way or another. If you go to the 3MF website, there's a compatibility matrix which shows which machine and software supports which extension, and all by default must support the basic mesh. So at the minimum, you'll get the smaller file size and watertight mesh. At the best, you'll have an implicit structure which is kilobytes instead of gigabytes. So it's time to think outside the triangle and or maybe think inside the triangle and consider adopting 3MF as a standard format for communicating data for additive manufacturing. Thank you. Any questions, please? How can we use 3MF for ANSYS? Good question. I just was in contact with some ANSYS people yesterday. So currently ANSYS does not support 3MF file format. So you still need to mesh it out as either a volumetric mesh or STL to get into their systems now. And for post-processing, so I think typically you want parametric for post-processing. Is that correct, Gaurav? So what I would recommend is continue to use the original CAD data. Where 3MF really sort of is most useful is when it's geometry that can't be handled by CAD, when it's more complex. So, but if you're doing machining processes, I think just continue using the same faces you're using from CAD. Okay, so although this is definitely improvement on STL, it does seem to address that most industrials still prefer BREP CAD. STL and 3MF loose model boss definition, the crucial modeling designs. Yeah, if you can use CAD, then if you can use the BREP data, then use BREP data. So the 3MF format is here for situations where you can't use the native CAD format. So I'm not saying that it's the answer to every situation. it's the answer to situations where CAD and STL does not work. Okay, another one, like in 3MF, more user. Do these updates and extensions work in earlier version CAD programs? Do you need the newest version after volumetric extension? So the question is, the new extensions require updates from the CAD and software vendors to support them. So I think using previous versions of the CAD software will not support new extensions, to my knowledge, because unless they're using something like Hoops. So TechSoft, a lot of software companies use TechSoft's Hoops as a translator. If they're just using those directories and to translate the geometry into 3MF, then older CAD systems may still work if they're calling on the most recent version of Hoops. But if it's native, then I think you have to go with the latest version of that CAD software to get the most out of the 3MF format. Yeah, and you can ping me on LinkedIn if you want to ask any more questions, and the website's 3mf.io for all the compatibility information. But yeah, feel free to reach out to me at any time. Thank you. Thanks for the opportunity, Rob. Appreciate it.
Thanks, Duann.